Remember that in this example, player one would have some beliefs about what player two is going to do. So he's going to believe that with probability theta 2 of H, player 2 would play H, and probability theta 2 of T, player 2 is going to play T. Or for simplicity, you might think with probability P and probability 1 minus P, because this is a simple 2 by 2 normal form game. Now, player 1 could either play heads or they could play tails. But there's no reason why player 1 shouldn't be able to also have some random choice between the two. For example, a strategy might be that player one would say, I'm going to flip a coin between heads and tails. So I'm going to play heads with probability 1/2 and tails with probability 1/2. Or maybe I'm going to play more generally heads with some probability q and tails with some probability 1 minus q. And q is just some number between 0 and 1. We call this a mixed strategy. And we're going to represent that using this strategy using the Greek letter lowercase sigma. So sigma 1 of H would be the probability with which player 1 is going to play H. Sigma 1 of T would be the probability with which player 1 is going to play T. In general, a mixed strategy is, for player I, an element of the set delta Si. So it's a probability distribution over I's strategies. If there is some strategy in the set Si such that sigma I of little si equals 1, in other words, if this strategy, sigma I, is such that the probability of lowercase si being played is 1, or lowercase si is going to be played for sure, then sigma I is what we call a pure strategy. Otherwise, sigma I is a mixed strategy. Because player I, in this case, would be mixing between multiple strategies in the set Si. There would be more than one strategy in capital Si that is played with positive probability by player I. So we call that a mixed strategy.